Good morning, ladies and gentlemen. Today's text, section 2.1b, limits graphically and numerically, and specifically we will be looking at two-sided limits as well as one-sided limits. Okay, almost every limit we've done thus far this year have been two-sided limits. We will look at one-sided limits as well and how the notation changes. But before we really get in there, especially because we're looking at it graphically, it really plays with your mind sometimes. The existence of a limit value as x approaches c never depends on how the function may or may not be defined at x equals c. Well, that's quite a mouthful, okay? That's quite a mouthful. So what does that actually mean? What that actually means is the value of f of c, when I plug that c value into my function, the value of f of c has absolutely no effect on the value of the limit as x approaches c. It's something you really got to grab onto, okay? These would be two good things to write down somewhere. They're not really theorems, I guess. They're Krugerisms, if I could say that. But we're going to continue on here, and we're going to take a little gander here, okay? One-sided and two-sided limits, okay? Now, when I'm looking at this theorem, Theorem 3, this is in your book, one-sided and two-sided limits. A function of f of x has a limit as x approaches c if and only if the right-hand and the left-hand limits exist at c and are equal. In symbols, it means this. The two-sided limit, the limit as x approaches c of f of x. Now notice there's not a little superscript above c here, is L. That implies the limit as x approaches c from the little plus right there, that would be the right side. The right-handed limit is L, and the left-handed limit with the little minus, that means that's the left-handed limit, because I'm approaching the same value L from the right as I am the left, the two-sided limit exists. So we really have to pay attention when we're looking at these limit values, okay? Am I doing a two-sided limit? Am I coming from the right or am I coming from the left? That's those little superscripts that are in there, okay? So we're going to consider this function f. And I'm going to draw f. And all I'm going to tell you is the domain of f is going to be from 0 to 4. Okay? And I'm going to draw this little thing. And we're going to say we're at 1. I got a closed circle. Or excuse me, at 0. I should put my 0 in there. And when x is 1, I have an open circle. And this is just going to kind of come down like that. Okay? And then right at 1, I'm going to jump up for a closed circle there, so f of 1 is actually going to equal 1. Then I'm going to come f of 2, I'm going to have a little open circle right here, horizontal line coming across, but actually f of 2 is this closed dot, so be copying this down on there. F of 3 is 3, and my graph is going to kind of come up like that. And then I'm going to say f of 4 is going to be 2, and we're going to say the function is going to kind of come in like this. So basically what I did is I have graphed a big ugly piecewise function consisting of, looks like about 3 different parabolas in a line, okay? So what we're going to do here is we are going to evaluate limits, okay? Make sure this is copied right here. Copy that graph on your page. If it's not on your page, we got a problem. Because your notes you got to follow that. So problem number 1, we want to find what is the limit as x approaches 0 from the right, because that little plus means the right side of f of x. What does that equal? Well, what I need to do is I need to come to my f graph, okay, and I need to be approaching 0 from the right hand. Obviously, this is the right hand of 0, okay? Duh, this would be the left side of 0. Okay, I'm going to get rid of those a second. What is the value approaching as x approaches 0? So as I get closer and closer and closer to 0, what is that function approaching? That function is approaching the number 1, okay? Makes no difference if it's an open circle, a closed circle, what have you. The limit of that function as I approach it from the right, that little superscript up there, is 1, okay? So what we're going to do here is evaluate a couple more, okay? They're never going to ask me, just if you're saying, why am I only looking from the right for number 1? Well, they're never going to ask you what it is from the left because the left side isn't even in the domain. I have no way to approach it from the left side because my domain is just from 0 to 4, okay? So now what I'm going to do is I'm going to look, what is the limit as x approaches 1 from the left here of f of x? So I got to come where x is 1. What am I approaching when I'm coming in from the left? What is the y value that graph is approaching as I get closer and closer to 1? And that value would be 0, okay? Well, let's look at the limit as x approaches 1 from the right side, okay? Well, what is that value approaching from the right? So that means I got to get up on my graph and I got to approach. Where's my graph coming in from the right? What is the y value that is approaching? It is approaching 1 from the right. So what is my limit as x approaches 1 of f of x? Now, there's no superscript on here. So what that is that's a two-sided limit. And if your limit is not approaching the exact same number on both sides, okay, there is no limit. Well, from the left, I'm approaching 0. From the right, I'm approaching 1. So this limit does not exist because I'm approaching two different specific values. One different value from the right and one different value from the left. Therefore, the limit does not exist. Now, typically in calculus, when they ask you, if you say the limit does not exist, you typically need to state why the limit doesn't exist. And the limit does not exist because the left is unequal to the right. That's why my two-sided limit would not exist, okay? Now I'm going to look down here. Let's check at 2. As I approach 2, that negative means from the left. So where am I from the left? I'm going to grab green this time. So as I approach 2 from the left, what is the y value I'm approaching? The y value I'm approaching is 1. As I approach 2 from the right-hand side, okay, bigger, as I approach 2 from the right, what y value am I approaching as I get closer and closer to 2? It is approaching 1, okay? So what is the limit? What is the two-sided limit as x approaches 2 of f of x? Well, it's 1. And I can see, as I put my finger on the left side here and I approach 2, as I put my finger on the graph and I approach 2, notice my fingers are coming together right there at 1. That's why the limit is 1, okay? Even though the actual value of f of 2 is 2, that has no bearing, okay? The value of f of c has absolutely no effect on the value of the limit, okay? Left and right side of that graph are approaching 1, therefore the limit's 1, but actually f of 2 would equal 2, but that we don't care about that. We're looking at the limit, okay? So let's come to the next page here. We're going to, well, same page for you. I'm going to do red here. What is the limit as x approaches 3? That little negative up there, remember, that means what? That means left. So as I'm getting closer to 3, what's the y value that's approaching? 3. As I'm approaching 3 from the right, that little plus means the right side. What am I approaching? 3. So what is my two-sided limit? Okay, notice I can see this as a one-sided limit with the superscript, one-sided limit with the superscript. There is no superscript, so this is a two-sided limit. And if the left is 3 and the right is 3, the two-sided limit is 3. If these numbers are different, that limit would not exist. Okay? Now notice, they're only asking me what's the limit as x approaches 4 from the left of f of x? Well, that's because the domain is only between 0 to 4, okay? So as I approach 4, what's my limit value? My limit value, remember, our y values, it's 2, okay? So what I really also want you to understand is, okay, none of these solid dots on this whole graph make a difference. If every dot I had was solid, like if I made this an open circle, if I made that an open circle, that an open circle, that an open circle, okay, that would not change any one of the answers from number 1 through 11. Open circle, closed circle has absolutely no bearing on the limit. Functional value does not matter when I think about a limit, okay? So what I'm going to do here is I'm going to come to the next page, and what I would like you to do is I'd like you to I'd like you to copy this example down on your page, okay? And then I'm going to hit pause, and I'm going to let you do these limits, and we're going to see how you turned out. And what we're going to do is we're going to say here at -1, we're going to have an open circle at 2. Then we're going to come down to an open circle at 0, and we're going to say, oh, f of 0 is 1. Then we're going to have an open circle here at f of 1, and we're going to make this little rascal kind of like a little parabola coming up. And we're going to say f of 2, yeah, let's make that up here at 4, and our graph is going to kind of come up to it like that. And then let's say f of 3 is undefined. That means that's open circle, but let's make it come to it like so. And then let's say f of 3, actually here, actual f of 3, I'm not going to say is undefined, it's defined, it's actually 2, and from there on out, it's a horizontal line. So copy that graph down, and what I'd like you to do is I'd like you to do A through I to see if you did them correctly. Back, hopefully you answered A through I, and I'm going to start on A. Now, please pay attention to the superscript here. What is the limit as x approaches 1 from the right of f of x? So as I approach 1 from the right side, I'm coming in right here, right? That limit would be 2. What is the limit as I approach 1 from the left of f of x? That would be coming in from the left side. That limit looks like it's 2. So what is the limit as x approaches 1? The 2-sided limit, no superscript. Well, if the left equals right, they're both 2. I can trace that on my graph. I can see this graph is coming together here and here, that if I kept going, my fingers would actually touch regardless of the open circle. What is the limit as x approaches 3 from the right side? So as I approach 3 from the right, what am I approaching? Well, I'm approaching 2. What am I approaching as I approach 3 from the left? Well, I guess I would be approaching 3. So what is my 2-sided limit? Because the right side is approaching 2, the left side is approaching 3. Those are 2 different values. That means this limit does not exist. Why does it not exist? Because the left limit is unequal to the right limit. Okay? How about the limit as f of x as x approaches 0 from the right? Well, as I come into 0 from the right, I'm approaching 1. As I approach 0 from the left, I'm approaching 1. The limit, the 2-sided limit, left equals right, so it would be 1. Hopefully you did all right on that, okay? So we're going to come here. Sometimes you're not given the graph. We're not going to graph this on the Nspire right now. What we're going to do is we're going to have to sketch this by hand. You got to think back to Algebra 2 and Pre-Calc. You got to remember, these are my domain values over here. When I have the equal to, remember, equal to is a solid dot. No equal to is an open dot. And all I'm going to do is I'm going to kind of lay this out. I'm going to say -3, -2, -1, 0, 1, 2, 3. My y is 1, 2, 3, 4. Now I got to be able to possibly graph a piecewise function. Would you have to be able to do this on the AP test? Possibly. So I'm kind of looking at this little bugger. Sometimes I'm going to look and I'm going to say, okay, well, 0, when I plug that in there, and I put a 0 in here, I get an ordered pair of 0, 1. So I get a closed dot at 0, 1. And I can see this is good for all x that are less than, so all this way of 0, which I can see the slope of that line is negative 1/2. So that would kind of come like that. And there would be the left side of that little bugger. The right side, well, I'll put my 0 in here, and I'm going to get the ordered pair 0, 1, which is going to be kind of like a little open circle here, if you remember that. And this is a parabola. So from there, I could make more. I could pick this one goes to the right of 0, and I could think of my old 1, 4, 9 if I wanted to. So I would have here, and I go over, up, 2, 3, 4. It's going to be up kind of here. And this side is going to kind of go up. Okay, so there's my graph if I had to graph it. Limits are super easy graphically, And I'm going to get rid of all this business. I'm going to get rid of that business, get rid of that business. And all I'm going to leave up there is please remember the open circle, closed circle via your inequality symbol, okay? So what is the limit as x approaches 0 from the left side? The negative means left. So as I approach 0 from the left side, what am I approaching? Looks like I'm approaching 1. How about as I'm approaching 0 from the right side? Looks like I'm approaching 1. I'm getting closer and closer and closer to that, okay? What does this mean? The left limit equals the right limit. This means the limit as x approaches 0 of f of x equals 1, okay? Just trying to point out, dictate, one-sided, two-sided via the notation that we have going on there, okay? Now, what happens if I didn't have time enough and I didn't have time to graph it? Well, how the heck do I evaluate a limit? What if I didn't have a graph? How do I find the limit algebraically? Super easy again, ladies and gentlemen. It's really not that difficult. I like to nest this in my mind, okay? And I like to kind of think upper piece, lower piece, piece 1, piece 2, however you want to do this. Now notice they're asking me the limit as I'm approaching 0 from the left and right. That's almost always unconditionally where they're going to ask you in a piecewise function where there's a potential break or jump in a graph to see if the limit exists or not. So what I like to do is I like to kind of look at this and say, oh, okay, well, this is for all x less than or equal to 0. Well, if I had a number line, okay, and I had 0 here, this is less than or equal to 0. That would make this the left side. So I would put a little limit, a little negative up there, meaning left side. This one is greater than 0, so that's this way. That's my right side. So to tell myself, oh, that's right side of 0. So I can just put those little pluses and minuses right into my piecewise function so that when I actually have to say, well, what is the limit as x approaches 0 from the left side, I only need to look at this top piece and plug in, direct substitute in to find out that limit is 1, okay? What is the limit as I approach from the right side? So because of that plus, I can find my right side. That means I get 0 squared plus 1, and I get 1, okay? Now, it's super important also to understand if they gave me this, okay, and they said find the limit as x approached 0 of f of x. This is a two-sided limit. The only way you can evaluate that two-sided limit is you must do both the left and right side. Don't fall into this inequality, which one includes 0. Please don't fall into that because it does not matter which one includes it, which one doesn't. Am I approaching the same number from the left and the right? If I am, the limit exists. In this case, that limit would have been 1, okay? Moving right along. Another one. We're not going to graph this one, okay? Notice this is really close to the same function, but it's a little bit different in that bottom piece. So This is for x is less than or equal to 0. I can see I'm approaching 0. Again, there they are there. And I can see less than, that's left, greater than 0 is right. So what I'm going to do is I'm going to plug 0 into my left. I can see that limit's 1. And I can see the right-handed limit is 2. Okay? What does that mean? What does that mean? That means the limit, if you were asked, as x approached 0 of f of x, as of f of x, that would equal does not exist. They didn't ask me that. That doesn't mean you have to do this every time, okay? But I'm just pointing out it does not exist. And if it doesn't exist, it's because the left is unequal to the right. That's why it doesn't exist. So what we're going to do is I'm going to quickly show you, grab your calculator. I'm going to show you how to enter a piecewise function into your calculator if you forgot, and we're going to have the calculator evaluate this for us too. Really good thing to be able to know how to do because you can check all your limits on your calculator all the time. Okay, so if we're going to graph that little rascal, first I'm going to say graph, and I want to show you with the graph because there's cool ways here. Now piecewise functions, I'm not going to grab anything in there. I'm going to grab this little thing right next to the book, and these are your two piecewise functions right here. The first one with the 4 boxes in it, that's a 2-piece only piecewise function. This one here with the 6 boxes, I can make as many pieces in that function as I want. We only have 2 pieces in this function, so I'm going to select that one. Now what I'm going to do here is I'm going to type in my function. So in the first box you actually type in the upper piece of your function. So I'm going to say negative, and I'm going to give it the old control divide 1 over 2 right arrow x plus 1. Then when I tab, it goes over here. That's where I got to set my domain for this one. And this is going to be for all x. Now all your inequality symbols are right above this equal sign, and because they're kind of a bluish color, depending what it is on your calculator, you got to hit control, and then you got to grab those little guys. We want less than or equal to 0. Then I'm going to tab again. It comes down to the next piece. Well, that piece is x squared plus 2 tab, and the domain for this piece is x is greater than 0. And then I'm going to hit graph, and it's going to graph that little bugger for me. So obviously graphically here I can see the limit does not exist at 0 like we did just before. Well, the nice thing about this is I don't always have to define the function, okay? I can add a calculator. I have defined my function in this calculator as of right now, this whole piecewise function. It is defined as f1 of x, okay? So if I wanted my calculator to find me the limit on here, and I wanted it to find it algebraically, I'm going to add a page. I'm going to add a calculator page, okay? And then I want to go menu, calculus, limits. And the limit is as x approaches 0. The first one we did was 0 from the left. Now, because this little box is a little bit more gray, it's not really black. If I'm doing a 2-sided limit, I don't type anything in there. But if I arrow over there and get up there and I want the left limit, I'm just going to hit the negative symbol down here to say left. And then I'm going to get into my function, and we've already defined this function in the calculator. The calculator knows that our piecewise function is f1 of x. And I come out, and we said that limit was 1. And what did I do wrong here? Hold on. Okay guys, I'm back. I saw the stupid thing I did. I'm going to toggle up and I'm going to grab that again. I'm going to toggle back in, and I'm taking the limit as x approaches. I put O, I didn't put 0. So as I approach 0 from the left, there it is, and then it's 1. Well, if I wanted to find that same limit, I can toggle up and grab it. But if I wanted the right-sided limit, I'm going to get rid of that, and I'm going to put a plus there. Okay, and then we found that to be, what did we find that limit to be? I think we found that limit to be 2. And if I needed to find the two-sided limit, all I would do is I would grab that same thing and I would toggle back, and I would make that, I'd put no superscript in there, and I'd find the two-sided limit. We found this does not exist because the left is 1, the right is 2. Therefore, those limits do not come together. So that limit is undefined, basically telling us it does not exist. Okay, so we're back and we found out that limit does not exist. So this next example, okay, what happens when, and even this one wasn't there, I kind of walked you through this step in my notebook again, okay? But what happens when the training wheels actually come off? Again, we're not going to graph this. We don't need to graph this. You can graph it if you want, but they're actually faster to evaluate algebraically many times, not all the time, okay? So we're not going to use that graph again. Now, this is a two-sided limit, okay, as x approaches 0. It is super important in order to do a two-sided limit, especially on a piecewise function. We cannot remember what is the limit, or we cannot forget as x approaches 0 from the left of f of x, and what is the limit as x approaches 0 from the right of f of x, okay? You must check both sides. Must check both sides in order to answer that question, okay? You have to check both sides. If you don't, well, you're going to be making a mistake sooner or later. And notice, when you see this piecewise function has 3 pieces in it. Guess where they're asking me for the first limit? You got to write that down. I'm asking you, okay, it's a domain jump here. Wow. So now I'm going to organize in my brain. Well, x is less than 0. This is my left-sided limit. And this is x is greater than 0. That would be my right-sided limit for these two. Now, what is the limit as x approaches 0 from the left? So I can also say left here for that 0. And as I plug that in, hopefully you can quickly see that limit's 2. What is it from the right side of 0? Well, if I plug that in there for the right side, what do I get? I get -1. Well, that tells me the only acceptable answer for a two-sided limit is does not exist. The reason why, left is unequal to the right, okay? It's important to state why the limit doesn't exist, number 1. And also number 2, you gotta read the notation. This means piecewise function, I must check left and right side. And if I don't, I'm being prepared to be making a potential mistake. Check it out. Where's the next place you're being asked for a limit on this piecewise function? Another spot where there could be a domain issue. It might come together, it might not come together, okay? This is, again, two-sided. So I'd think I got to remember, what is the limit as x approaches 2 from the left of f of x? And what is the limit as x approaches 2 from the right of f of x? Okay? Got to know them both. Got to check both sides to answer that question. Okay? So I'm thinking left side. Well, these are x's less than 2 left, greater than 2 right. And I don't need to, there's not a lot of work for me to show in here. But if I'm looking for the left of 2, well, isn't that really 2 squared minus 1, or 4 minus 1 to give me 3? All I do is substitute that 2, because I'm looking at 2, into my function and evaluate it. Okay, well, what is it on the right side? Again, the right side's right here. I plug it in there. That's going to give me 6 minus 3. What's 6 minus 3? That limit's 3. Oh, so the limit as x approaches 2 does exist. It's 3. The limit does not exist at 0, but it does at 2, I should say, not 3, okay? So that's graphically. That's not using graphs, okay? That's algebraically. You just need to figure out which piece and part you got to put it in. Please don't forget, if it's a two-sided limit, you have to check both sides. The AP test is very rarely going to lay this out for you, okay? It's classic that they would ask you this question to check your limits. This would be a great one because what a lot of people would do would say, oh, zero's in the domain here, so my limit must be 2, and they'd be wrong because the limit does not exist. It's approaching two different numbers, a different number from the right to a different number from the left, okay? The next thing we're going to look here quick is classic AP problems here as well. Here's my function f of x, no graph, no equation, no nothing, just a table of values, and I can see what is the limit as I approach 5, okay? So this would be my left side because I'm coming in from numbers under. This would be my right side. What is the y value that is getting approached from the left and right at the same time? 6. You can just read it right out of your table, okay? Okay, what is actually happening there on number 1? Why is it undefined? Oh, I'm coming together. I'm coming together, but I'm undefined. That's a hole in the graph, guys. That's the hole in the graph. That's what's happening there. There's a hole in the function. Okay, well, what's my limit as I approach -2? This is two-sided limit again. So left would be coming in, right would be coming in, okay? What am I approaching? All I see as I'm approaching from the right, I'm getting really big and negative. As I'm approaching from the left, I'm getting really big and negative. Well, as I get closer and closer, my numbers get bigger and bigger. Am I approaching a specific value? Answer is no. The limit does not exist. Okay? This is a vertical asymptote. Okay? It is technically called unbounded behavior. Why does the limit not exist? Unbounded behavior. Vertical asymptote there, okay? Sometimes they're going to ask you for directionality of the graph. If it were multiple choice and they didn't have does not exist, they're going to say, hey, what's the limit? Well, technically, it's giving me the direction of negative infinity because negative infinity is not a specific value, implies it does not exist. But it gives you the direction that the function is going, okay? So it would still be no, does not exist, negative infinity for a direction. You don't have to give the direction unless it would be asked for. Reason why? Unbounded behavior, because I'm crawling up a vertical asymptote. This next one right here, classic. I've seen these problems on virtually every practice AP exam I've ever seen, okay? Find the value or values, could be plural, could be one value or two values of A, so that the limit of f of x does exist at -1. Okay? So I have a piecewise function here. Got myself a cute little piecewise function. It's only two pieces. I need to find the magical number for A that is going to make this limit exist. Well, let's think about this. What did we just get done learning for a limit, the limit as I approach -1, two-sided limit, two-sided, because there's no superscript on there. What did I just learn has to happen for that to work? Well, that means the limit as x approaches -1 from the left of f of x, that has to equal the limit as x approaches -1 from the right of f of x, okay? Well, what is my limit as I approach -1 from the left? Well, x is less than or equal, that would be left, greater than, that would be right. What is my limit? I take my -1 and I plug it in there. Well, what, -1 cubed, that's going to give me basically negative 1 to the third minus 4 times negative 1. What does that give me? Well, that gives me negative 1 plus 4. So the left-sided limit is 3, correct? Well, what is my right-sided limit? Well, I find my right-sided limit for plugging negative 1 in for x. Only x, so that comes in there. So I have negative 2. No, I don't. I have positive. I have 2 times negative 1 plus a. Well, that means my right-sided limit would be negative 2 plus a. I wonder what a would have to be to make these two equal. A would have to equal 5, wouldn't it? All I'm doing is I'm solving this little linear equation that I had there. So a would have to be 5 for that to make it happen. Well, obviously I can check that because my limit as I approach from the left was 3 here. As I approach from the right side, negative 2 plus what is going to give me 3? Yeah, it would be 5. However, these typically are the types of problems that show up on the free response test. Definitely they are looking that you're setting the left and right limit equal to each other, and if you do not do the left and right limit equal to each other, lots of times they call it a bald answer and they won't give you any credit for it. So work, you do that, then you set the limits equal to each other, and finally you solve. If this equation right here were quadratic, I would possibly have 2 different. If it were cubic, I could have 3 different values, okay? So classic, very classic. I promise you one of these on your test too. And my finger can't get close enough to the edge over there, which is kind of annoying. So I'm gonna bring it over just a skosh because it's annoying. And now I'm gonna be able to get it. There, now I'm happy. Okay. Okay, the last one here, we're gonna explore this limit using your grapher. This is a tough one. You really got to wrap your mind around this one. It's a pretty important one. So not to beat it to death, but what I'm going to do is I'm going to grab my grapher. Hopefully you got yours. I'm going to add a graph, and I want to graph sine of 1 divided by x, and enter that. And we're looking for the limit as I approach 0. Okay. And as I approach 0, it's like, well, it's kind of getting wiggly and squiggly in there a little bit, but good thing I got a graph because I know how to evaluate these things with graphs. I can say menu, analyze graph. Nope, we want to trace it. Sorry, trace graph. And I can see right at 0. It should be giving me, why is it not tracing me at 0? It's really not showing me what, well, it's showing a really nifty one there, but let's go point 1. Point 1, I'm at negative a half, 0.01. And looks like it's coming into a negative a half. As we hit 3 decimal places, typically 0.0001, boom, oh, whoop, now it changed. That's kind of strange. Went negative a half, I think we would agree at 0.001, I'm pretty stinking close to 0. I would think we would agree at 0.01, we're pretty stinking close to 0, but there's a gross difference there. Well, let's escape out of the tracer. Let's go menu. Let's change our window settings here, and let's really zoom in here. Let's go from -1 to 1, and I can see by the height, I'm going to go -2 to 2. And whoa, looks kind of wonky there. And as I am trying to trace it, it still looks like it goes, excuse me, through 0. Let me try to trace this little bugger again, trace the graph. 0 undefined, it gives me right there. 0.1231, and I'm -0.3. If I did 0.12344 zeros 1,
Well, now I'm positive 0.03. How about 1, 2, 3, 4, 5 zeros and then a 1? Well, crap, I'm back to negative. 1, 2, 3, 4, 5, 6 zeros and then a 1. Well, this is really kind of crazy. I really don't get it. I mean, I'm seeing a narrow window here. I mean, I could continue on and on. I could take my window zoom, I could take my window settings, and I could go from negative 0.1 to 0.1, and I could really zoom in, and all I see is more stuff going on. What in the heck is going on here? Well, here's what's going on here. As I'm approaching 0, as x goes to 0, it never gets to 0. So think about this. What is 1 divided by very small? 1 divided by very small is very big, right? Just like 1 divided by very big is 0, 1 divided by very small is very big. So it's the sign of bigger and bigger and bigger. Okay, so that number, this is getting bigger and bigger and bigger, which goes into the sign, and it keeps popping out. The closer I get to 0, it keeps popping all kinds of crazy stuff that's all listed between 1 and negative 1. Well, that's weird. Why is that? You know why that is, right? Because all my sine functions, where do we get all these numbers for the sine function? Well, we got that cute little thing called the unit circle. And on the unit circle, the sign goes 1, 0, 0, 1, negative 1, 0, 0, negative 1, okay? And now think about this a second. All this is doing, all that sine function is popping out, is numbers between 1 and negative 1, right? The wavelength, the amplitude, height, it's always pushing that out. And what I'm doing is I'm putting a bigger and bigger and bigger number in there. But all that does is that controls how many times around the unit circle I'm going. I'm going around and around. It gets bigger. I keep going on, and it's stopping at a random point here. Negative. Keeps going around and stops at a random point. Positive. And because I'm always bopping around on the unit circle, yeah, this number is getting super huge, but I'm just landing somewhere on the unit circle between 1 and negative 1. Where? We don't know. We don't know because that number is just getting bigger and bigger. So it's just more times going around and around and around. So how do I answer this question? Well, is it approaching a specific value? Answer, big fat no. This limit does not exist. It's approaching an infinite number of different values between negative 1 and 1, none of which is specific at 0 because I keep going around that circle. So the reason this does not exist is it's oscillating behavior. Okay? It's oscillating behavior. That's why it does not exist. So process it a little bit and hopefully it'll make sense. Have a good rest of your day. You should be able to do all of the homework in 2.1b. Talk to you tomorrow.